Hello everyone. Today let's solve the problem number 102, binary tree level order traversal. Right. So what the question states here, we are given the root of a binary tree. Right. So we have been given the root of the binary tree here. So we have to return the level order traversal of its node values. So we have to return the level order traversal of its node values. Right. So just keep this in mind. That's what they have asked us to do. We have to return the level order traversal of its nodes value. That is nothing but from left to right, level by level. Right. So let's come to the first example here. In this case, we have 3. Right. So we have 3, 9, 20. Null. Here we don't have anything left and right subtree for the this one. 9. We don't have children for the 9. Right. So it will be considered as null for the input, and 15 and 7. In the output, what we need to return here, first level is this one, right? 3 we need to return. Second level is this one, 9 and 20. From left to right they have asked. So it will be 3, 9, 20. And let's come to the third level here. We have null. We will ignore this one in the output. Null will not consider. Here in this case, we will consider 15 and 7 from left to right. This is third level, right? So this is first level. This is second level. This is third level. For the third level, we will be considering here in this case 15 and 7. Right. So that's what we need to return in the form of output. See here, 3, 9, 20, 15 and 7. So I hope this is completely clear. Let's come to the second example here. We have only one, this one, right? We have only one node here. So it will be present at the first level, root node. So we will return that itself 1 within the new array, right? So this is fine. So the third example here is we have empty row. We don't have any node here at all, right? So we'll just return the empty array as output in that case. So this is fine. I hope they have given wonderful examples, right? Just for the sake of understanding here. I hope this is clear. So I hope question is clear. I hope the question is completely clear. Whatever we need to do is completely clear as well. What to do? I mean, what we need to do is completely clear as well, right? So first, let's discuss the approach followed by the edge cases one by one, and then let's write the code and discuss the complexities for the code that we have written. Initially, let's discuss the approach. So let me clean up this one. Just give me a second here in this case. So yeah, first, what we will do, let's discuss the approach. So the first thing that we need to keep in mind here is we will be going with a breadth first search, right? We will be going with a breadth first search with Q, right? Why we are going with the BFS here? Because we have to find out this one level by level. We have to return the output level by level. Whenever we need to return something or we need to find something level by level, then it is better to go with the BFS. We can do this one with the DFS as well. We can just keep this in mind. Any tree problem can be solved with either DFS or BFS. Just keep this in mind. We can go with the DFS, we can go with the BFS as well. So whenever they have asked us to find something level by level, it's better to go with the BFS. Just keep this in mind, right? So I have considered the first example, the same example that they have given in the question, so that it will be easier to understand, right? So we'll be going with the BFS with Q. This we have already discussed. 3, 9, 20, null, 15, 7 they have given. So output has to be each level. At each level we have to push the value to the new array, right? So 3 first level, 9, 20 second level, we have pushed this one to the new array. At the third level we have pushed 15 and 7. So now let's discuss the step-by-step execution, right? So first we will start with the queue, initialize that queue that is initialized with the root 3, first one. So this one we are speaking of, right? So first what we'll do, we'll start with the queue that is initialized with the root 3. Easy, right? So next we will process the first level. At the first level we have to process 3 itself, right? We had 3 at the first level. We will process this one. This is fine. So we will process 3 and then we will add its children 9 and 20 to the queue. We will be adding 9 and 20 to the queue, right? So next step, third step, let's move on with the third step here. Just give me a second here. We'll move on with the third step here. We will process the second level, nothing but 920 here in this case. I have already written this one. We have just added to the queue 9 and 2. So now we will process 9 and 20, right? So this has to be 20. Sorry. So we will process the second level, nothing but 9 and 20, and add their children 15 and 7 to the queue. We have now added 15 and 7 to the queue. Just keep this in mind. Let's move on to the fourth step here. we have to process the third level. Nothing but we have already added 15 and 7 to the queue. So now we are processing the third level. Nothing but we will add 15 comma 7. This one will process 15 comma 7 as no more children are present to add, right? So this is the last one. This is the last level, third level, right? So final output. So after processing here, just give me a second. After processing here, we will get here 15 and 7, right? So the final output is 3. At first level we added this one. At second level we added 9 and 20, and at the third level we have added 15 and 7, right? I hope this is completely clear. 3, 9, 20, 15 and 7. This is fine. So the final output is this one, right? So the final output that we got is 3, 9, 20, 15 and 7. At each level, we are adding its value to the newer array. You can clearly see here, right? So I hope this is clear. The output that we got is equivalent to the output that they have given for the first example, 3, 9, 20, 15, 7. So the approach works absolutely correct in this case. So the approach works absolutely correct in this case. Now we are familiar with the approach. Let's quickly discuss the edge cases, right? So let me come to the first edge case here, empty tree. So root is empty here in this case. Output, we have to return the empty array. We have already discussed this one in the third example, right? I think. So in the question they have given the same, the second example or third example. So this is second example, I think. This goes with a single node. Root we have 1. We have returned the same thing here, right? We have only one value here, right? So we have to return the same thing. So this is for the empty tree. This is for the single node. Let's move on with the third edge case here. Tree with only left children. We have 1, 2, null 3. So this will be 1, 2. Here this will be null and this will be 3, right? So output will be at first level this will be added, and the second level will process 2. At third level we will process 3. First we will process 1 and add 2 to the queue, and then we will process 2 and add 3 to the queue, and then we will process 3 and add 3 to the queue. This one will be the output. Same thing goes with the fourth edge case as well. Tree with only right subtree. Here this one will be 1, null 2, null 3, right? So first we will add this one to the queue and we will process 1. When we process 1, we will add 2 to the queue. First level we will add 2 to the queue. So after processing 1, we will add this one. We will process 2, which is at the second level, and we will add 3 to the queue. After processing 2, we will process 3 and add there is no value next to the 3, right? So here we will stop at the third level, right? So this one, 1, 2, 3, right? This is fine. So these are the edge cases that we need to consider here. So the first edge case is for the empty tree, the second edge case is for the single node, the third edge case is for tree with only left children, and the fourth edge case is for this one, tree with only right children, right? So these are the 4 edge cases that we need to consider. So now we are completely familiar with the edge cases as well as this one. What do you call? Approach. So now we are completely familiar with the approach as well as the edge cases, right? So it will be easier to write the code now. Let's start. So yeah, first step here is we have to store the final level order traversal somewhere, right? So for that one, we'll be making use of the array list. Let's make use of array list here. So I'll quickly come here. Let me give list. So list this one. So type integer. So I'll just mention integer here. This is fine. So did I miss something here? List integer. Yeah, this is fine. So I'll just make use of the variable name result here. So I'll just give here new array list. This is fine. Next step is if true, if tree is empty, then we have to return the empty list. This we have discussed in the edge case. If tree is empty, we have to return the empty list, right? The base case. So here in this case, if root equals null, then what we will do? We will return null. Simple to understand, right? Let's move on with the next step here. We will be making use of the queue to store the nodes for BFS traversal. We have already discussed this one. We are going with the BFS. I have said this one multiple times during the approach that we will be going with the BFS with queue, right? So we will be making use of the queue to store the nodes for BFS traversal. So let me give here queue tree node in this case. So I'll just give queue equals new linked list. This one is fine. So we will start with the root node. So always we'll start with the root node in the queue, right? So I'll just give here queue. I'll just make use of the property add here, right? Add of root. So first we will add the root, then we'll process the same thing. We'll after processing, while processing the root, we will add the next value. Like that itself, we will move forward, right? So in this case, first step is we will start with the root node. So after this one, we have to traverse level by level, right? So we have to traverse level by level. Let me quickly write the while loop here. While not of queue, this has to be true, right? Queue shouldn't be empty. Then only we can traverse further, right? So in this case, while queue is not empty, then what we will do? We have to get the number of nodes at each level or at current level first. We have to get the number of nodes at current level, right? So I'll just make use of here in level, or I'll just give here level size, right? So this will be q dot size. This is fine. So the next step here is we have to store the values of current level. So we have to store the values of current level at each step, right? So I'll just go with list, right? So we have made use of the list. We have initialized the array list, right? Initial. So list of integer. Let me go with the variable name current level. This will be good actually. Current level. This is fine. Current level equals. Let me initialize this one. Array list. So let's create the array list. Sorry. So this is fine. So this is fine. So the next step here is after we have to store values of current level, right? For that one, we have created the array list. This is fine. So we have to process all nodes in the current level. So whatever the node that is present in the current level, we have to process all the nodes in the current level. For that one, let's go with the iteration quickly. Let me make use of the for loop here. For let, not let here. So this is JavaScript, right? So I mean, so this is Java, sorry, right? So I'll just go with the int here, I equals 0, I less than level size. This one, let me increment the I here. This is fine. So the next step, we will remove the front node from the queue. Always we have to remove the front node from the queue and process the next level, right? So for that one, sorry, I'll just go with here tree node equals queue dot. I'll just make use of the poll property to remove the node from the queue, right? So this is fine. So next step is we have to add the value to the current level list. So I'll just we have given current level. I'll just give here. I'll just make use of the property add here. Add of value of the node we have to add. So I'll just go with node.val here. Simple. So the next step, if the left child exists, then we have to add that one to the queue. If the right child exists, then also we have to add that one to the queue. When we are processing the root node, suppose if we are processing the root node, then if it contains left and right nodes in the next level, if the left and right child exists, then we have to add that one to the queue, right? So let's write the simple if condition for that. So I'll just go with if node dot left means left node not equal to null. We are just going step by step right here. If node dot left not equal to null, then we will add that one to the queue. Queue dot add here node dot left. This is fine. So let this is fine. Let me copy these two lines here in this case. So let me paste this one. If node dot right here, this one is fine, not equal to null, q dot add of node dot right. Instead of left, I'll just make this one right. So if the right and left children exist, then we have to add that one to the queue. That's what we have done here until line number 22. Let's move on with the next step, right? Let's move on with the next step. Here we have to add the current level list to the result. Result means result variable, right? So finally we need all the values of the nodes at each level that has to be pushed to the newer array, right? So that is the reason we are adding this one to the result. So we are adding the current level list to the result. So I'll just give here result dot add of what we need to add here, current level. So let me come here, let me copy current level. I don't want to type this one. So this is fine. Current level. Finally, what I'll do, we have to return the final level order traversal. Nothing but in this case, return result. This is fine. So this is it for the code. Let me format the code once here and let me hit the run button. Let me format the code once and let me hit the run button. So here we have here. So what the error states here? Tree variable variable tree. Oh yeah, I have just mentioned tree node here, line number 15. So yeah, this one, let me give node here. I mention node here. This is fine. So let me hit the run button again. Oh, I have misspelled current here, line number 16. So I'll just remove this one, current. Now this is fine. Let me hit the run button again. Again one more error. So again I have the error here. Same thing. I have misspelled current here. This is fine. Let me hit the run button again. Hope this works now. Let's see. Wrong answer. We are getting null instead of the empty array. Let's see what we have done. So here in the line number 12, I have forgot to mention the generics here, right? So the angle brackets I'm speaking of. So let me give angle brackets here. So let me hit the run button again. So let's see whether this works. This has to work now. Let's see. Again we are getting wrong answer. So why? So yeah, one more thing here in the line number 5. So if you observe here, if root is null, then we have to return the empty list, right? We don't have to return null. So I get confused with JavaScript basically, right? So don't mind. So I'll just give here in this case return a result. So if the tree is empty, we have to return the empty list. In this case, we have to return the empty list, means return the result, right? So let me format this one and let me hit the run button. I hope this works. This has to work now. Let's see. Yeah. Now you can clearly see the sample test cases are getting passed. So let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct on this case, right? So let's quickly discuss the complexities for the code that we have written. So one thing, or the first thing here is the approach that we went with here is breadth first search, BFS, using the queue. We know this one, right? So we have went with BFS with queue. We have already discussed this one. So overall time complexity would be here big O of n. So why it is big O of n here? Because we are processing the each node exactly once. We know this one, right? We are processing each node exactly once here. So total operations are proportional to the number of nodes that is present, right? So total operations are proportional to the total number of nodes that is present. So overall time complexity would be quite obviously big of n in this case. So what would be the space complexity here? So the overall space complexity would be big of n as well. Why it is big of n here? Because in the worst case, the queue stores all the nodes at the last level, right? So in the worst case, again I'm telling, this is simple, right? So in the worst case, the queue stores all the nodes at the last level, which can be big O of n by 2. Nothing but overall space complexity would be big of n. Big O of n by 2, that is equal to big O of n. So overall space complexity would be big O of n, right, in this case. So the time complexity would be big O of n, and the space complexity would be big O of n as well for the code that we have written, right? I hope the complexities are clear, and I hope whatever the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching, guys.